multiplying numbers in scientific notation. Way back when, a long time ago, we went over the fact that when we were multiplying exponents, when we're talking about tens, like for example, 10 to the second times 10 to the fourth, when we're multiplying exponents, what do we do with those exponents? We add them. We get 10 to the sixth, if you recall that. Well, we're going to use that, and that was lesson 47 or something. We are going to use that process today when we talk about numbers in scientific notation. So when we multiply numbers in scientific notation, we can use that same process. So for example, if we were multiplying 4.2, 4 and 2 tenths times 10 to the 6th power times 1 and 4 tenths times 10 to the 3rd power, to multiply that problem, our first step would be to do the number part, 4.2 times 1.4. Anybody know what that is? Solve it for me, please. 4.2 times 1.4. Very good. All right, so 5.88. Good. Times 10 to the what power? Well, what's 2 plus 4? Oh, sorry, I'm looking over here. I shouldn't have looked over there. 6 plus 3? 9. Should have erased that problem. I could confuse myself. So 5.88 times 10 to the 9. Is 5.88 in correct form for scientific notation? Is a decimal after the first number that's not 0? Nod your head yes. So it's in correct form, and I don't have to do anything else to this problem. It's done. If it was not in correct form, there would be a little bit I'd have to do to change that. But we'll get to that in a little bit. Let's try another one. How about this one will not be in correct form? All right, what's 5 times 3? 15. 15 times 10 to the 12th power, because 7 plus 5 is 12. So we did 5 times 3, and we did 10 to the 5th times 10 to the 7th to get that. This is not in correct form. For scientific notation, for correct form, we need to have our decimal behind the first number that's not 0. So what's the first number that's not 0? 1. Where's our decimal right now? It's behind the 5. So to move, I have to go one place right here, correct? So now that's 1.5 times 10. That changes our exponent up by 1. Anytime you move the decimal to the left, each place that you move it makes the exponent go up by 1. So we moved it one place. So our exponent's going to go up 1 spot. So now it's times 10 to the 13th power. And all scientific notation is a way to write either very big or very small numbers in a shorter form. And it's a way to multiply them and divide them more quickly than dealing with larger numbers. Let's try another one. This time, this one's going to have negative exponents, so I'll change the color. 4 times 10 to the negative 3rd times 2.1 times 10 to the negative 7th power. Okay, so what should my first step be? 2.1 times 4. 8.4. Right? 8.4? That's in correct form, correct? I don't need to change that because my decimals behind the first number is not 0. Times 10. Add our exponents. They're both negative. So negative 10th power. Very good. 8.4 times 10 to the negative 10th power. Pretty straightforward, right? So we did 2 steps on that one, and we were able to solve it pretty quickly. All right, so D. Another one. 6 times 10 to the negative second times 7 times 10 to the negative fifth power. What's 7 times 6? 42. Times 10 to the negative 7. Not in correct form. The decimal's behind the, it's behind the 2. We want it to be behind the 4. Okay, so now that's 4.2, so that means I moved it one place, times 10. So add 1 to negative 7.
Wait, no, it would be negative 6.
It would be negative 6. Negative 6 is bigger than negative 7, right? So it did go up 1, but we had to subtract to do that. All right, that's why I showed you a negative number. Does that make sense, though?
Yeah.
Because we had to add 1. So basically, each place you have to move the decimal to the left, you add that many numbers. If I had to move it 10 places to the left, I would add 10. Later on, when we divide these, we'll be moving the decimal to the right. But today, we won't worry about that. All right, so if you were told to justify or explain how you would do this, that's the problem that you've been given without parentheses. What would be your first step?
3 times 2.
All right, you would do 3 times 2 equals 6, and then you would do 10 to the third times 10 to the fourth. All right, which would be 10 to the 7th power. Now, anyone know way back when what that's called when we can, in multiplication, move the order around? There's a term for that. It starts with C.
Oh, a commutative?
Commutative property of multiplication. Remember that? So if you were told to explain it, and when you take algebra in geometry in high school, you'll be doing these things called proofs. And you can ask Caleb's brother about proofs. And in proofs, you're kind of explaining how to do the problem. You're proving it. This is one of the steps involved. You're explaining how to do this problem. Well, you showed it, but what's the term? It's the commutative property of multiplication. All right? Now, there's another way you could show this problem as well. You could show it like this. And it's how we solved it. Like, we kind of embedded it into what we did. What is that called when I start throwing the parentheses out? That's one started with the associative. Very good. So that was the associative property. Associative property is how we can. Commutative lets us move the order around. Associative property lets us do the order in a specific way by adding parentheses. But what do we end up with as an answer? 6 times 10 to the 7th power. Do I have to do anything else to it? No, because my decimal is behind the 6, even though it's not drawn. Any questions on that stuff? Pretty easy today. If no further questions on this, I'm done with you. I will be answering questions in a little bit.